Good morning, everybody. So my name is Matthias Delpley. I'm working for the Suez company. I'm going to tell you about monitoring and forecasting nearshore water quality in real time as part of a service that we are providing, a service for decision support for water quality in bathing areas management. So first, a few words about our team. So I work for a center called Rivages Protect, which is a center dedicated to ocean application inside the Suez company. And so we are 14 persons based in Biarritz and Bordeaux. And the solutions we are providing are based on metocean technologies combining online monitoring and short-term forecasting in real time using numerical models. Together with 24-hour and 7 days expert team consulting based on this tool. And we have several applications. So an application to river and nearshore water quality management, the one I will talk about today, but also applications about storm surge management during extreme events. Applications about marine renewable energies, or also floating marine litter management. And so regarding the nearshore water quality management service, our main application sites are the southwest of the Aquitaine coast in France and in the Mediterranean Sea, the Bay of Marseille. So here are some drivers of this service regarding water quality monitoring. So we got today 7 million inhabitants in the coastal area, and 4 million more are expected in 2040. And another indicator is of the stress that is of the stress on the coastal area and coastal water quality, that the coastal building activities are today 3 times higher in the coastal area than in the average for France. Tourism is also a really important part of the economy of most of the coastal areas. So it stands for 40% of the marine economy added value, 50% of the employments, and next to that we got 40% of pollution events that are related to terrestrial contaminants, and so to contaminants inputs that are related to human activities on the coastal watersheds. So there is a major challenge in managing the water quality, especially in coastal areas that are urbanized, because these areas are seeing most of the stress related to contaminated inputs, especially during raining events. Next to that, we have also strong regulatory drivers with the evolutions of the regulations during the past 10 years, with the Water Framework Directive and the Bathing Water Directive, that are installing more higher quality standard requirements for water quality, especially in bathing areas. Also, frequent controls by the National Health Agency, Regional Health Agency in France. So to give you an order of magnitude, during the summer season we get between 1 and 2 official controls of the water quality per week for each bathing area. And so in case of too bad quality evaluation by this control organism, the major consequence can be mandatory closure of the bathing area of the beach, with a maximum duration up to 1 year until the water quality is improved. And so the service we are providing is aimed at bringing some elements to help managing this issue of water quality around bathing areas. And so it is based on real-time monitoring and forecasting of the nearshore environment and of its quality. So the solution is based on an operational platform which is called Influx, which is a platform developed by the Suez company that aims at managing together real-time monitoring information and real-time numerical modeling of the river and nearshore ocean, to provide forecasts of the evolution of the water quality close to the beaches, and then data analytics, data integration about the collected information and the information produced by the model to support decision. So basically the system is accomplishing three major type of actions, of tasks. The first one is to collect information, which means information from outside the system, like the information from the CMEMS, CMEMS services. Then to predict the evolution of the nearshore water quality based on numerical models, and then to integrate this data to produce indicators to support decision. Here are the type of information that are collected by the system. So information about receiving water quality measurements that can be performed every day or several times a day during high-risk periods. Information about the sewerage system that is, in most of the case, one of the major contaminant source for the nearshore area. Then information about the meteorology and the ocean dynamics, where we use the CMEMS project's data, and information about the rivers and the related inputs in the nearshore area. Then we got the functional block providing forecasts based on numerical models. So we use, in fact, several numerical models that are articulated one to each other. And the idea is to get an information, a high-resolution information close to the beaches. And so typically we are working with spatial resolution which range from 100 meters to 10 meters, and with time resolution from of the order of the hour. And so we use typically numerical models of watersheds, of sea states, and then of nearshore hydrodynamics and transport, especially contaminants transport. And so here is an example of the output of such a model. So what you are seeing in color is concentration in bacterial, in some fecal indicator bacteria. And you see how the model is simulating the response of the nearshore area. And so it's the side of Biarritz and the beaches from Biarritz. And you see over the time the answer of the nearshore water quality to the inputs, mainly here from the sewerage system of the city. And so based on this information, we got an estimation of the water quality through space and across the space and along the time, and so we can compute some indicators of the related risks for the use of the nearshore water based on such forecasts. And so that the aim of the last part of the system, which is integrating this data with different levels of detail depending on the user that is targeted by the service. So we have very integrated indicators which are intended to help decision support every day. Then we have a more detailed level of information, for example, to understand more deeply the risky events or the risk factors during one pollution event. And then, so several risk indicators to characterize the impact of the different components of the system, like the importance of the outflow from the sewerage system, or the importance of the outflow from rivers, and all this information. And so the system allows to provide alerts in real time in case of an important risk. It is used then to optimize the bathing area closure periods, so to ensure a good quality when the bathing area is open, but to decide of preventive closure when there is a risk for the users, but to minimize as much as possible these periods of closure. Then this information also used to optimize the sampling strategy. So based on the information from the model, we can distribute the points where we are doing measurements to provide the most interesting information. And then we are also working at using this system that provides information about the response of the receiving waters to influence the functioning of the sewer system, so to optimize the functioning of the sewer network, of the sewer system, to minimize the impact on the receiving waters. And so here are the CMEMS products that we are using, so the main products that we are using for now. So it's mainly regional numerical model forecasts that we use in real time as boundary condition for our coastal and nearshore model. And then we are downscaling this solution to reach the resolution, spatial resolution especially, that we need to for our service. And so on the Mediterranean Sea, we use the Mediterranean forecast system based on the NEMO hydrodynamic model. And then for our Atlantic application, we use the EB ocean analysis and forecasting system. And the information that we are using to force the model are mainly currents, temperature, and salinity offshore, and then also water level also. And so here are some elements to try to illustrate the impact of the service and the related issues. So the service is dedicated for two different types of end users. So our main end user, which is also our client, is a local authority that is in charge of managing bathing water quality. So typically in France, it is the group of cities or the cities. And so this service is implemented for three major agglomerations. I mean, the agglomeration of Marseille on the Mediterranean coast, and the two agglomerations of the French Basque Country of the Atlantic coast. And so it represents a significant number of cities like Marseille, Biarritz, Anglet, Bidart, and other cities that are concerned by this service. And so the second level of end users that are targeted by this service is the beaches users, so the public that is using the beaches for recreational activity mainly. And so this end user is informed of the information provided by the system through mobile applications mainly. And so in collaboration with the municipalities, with the cities, we give access to the public to information about water quality in real time as provided by the system. And so to talk about economical impact, I took the example of the French Basque Country because there are several studies about the economic impacts of bad water quality that were conducted during the last years. And so it was estimated that the tourism activity during the summer season represents 1.4 million of overnight stays for the whole French Basque Country, and among them 240,000 overnight from people from foreign countries. And so 68% of the tourist visits are related with ocean activity and attractivity for the ocean. And then it was estimated by this study that 19% of the tourists would not come back to the French Basque Country if some durable water quality problems occurred. And so it represents a loss, a decrease of the revenue related to the tourism that was estimated around 71 million euros only for the southern part of the French Basque Country. And so there is another study that were conducted by the municipalities of the French Basque Country. They studied the cost on touristic activity of the closure of one beach during one day during the summer season, and they evaluated that the related cost was 150 kilo euros per day. And so for some risky areas like the French Basque Country, we can have regularly from 5 to 10 preventive beach closure during the summer season. So it represents potential loss for touristic activities of 1.5 million euros. And so this, all these numbers to illustrate that there is a strong need of public health protection, of course, and of preventing warnings to ensure that the there is no risk for public health, but there is also a real need for an optimization of this beach closure periods to limit the economic impacts. And so this is the last part of my presentation. I will tell you about the recent application that we are developing, and which involves CMEMS projects. So we are working at combining different type of monitoring solutions with numerical models to improve the performance of the numerical modeling of the coastal river plumes, and also smaller plumes related to outflow from marine outfall of the sewer system. And so basically we are using traditional water measurement through water sampling, a bit more original measurement from GPS track drifter. Here you see an example of such a release of GPS track drifter in the Adour estuary in the southwest of France. But most of all, we are working at combining numerical modeling with satellite observations. So this work is conducted in collaboration with the Telespazio company, which is an expert in remote sensing and satellite data, use of satellite data. So Telespazio brings the expertise about satellite data, and we bring the expertise about numerical modeling, and we are working together to combine both of this expertise. And so we are working at evaluating surface turbidity and suspended matter concentrations based on high resolution satellite information, with the resolution sufficient to resolve large river plumes, but also smaller river plumes and smaller plumes that are related with outflow from the sewer system. And here are some results that we produced recently with Telespazio. So you can see on the right part of the slide a result of the model in the upper part simulating the dispersion of the Adour river plume. And then you can see on the lower part for two different time instants an evaluation of the localization of the river plume in the surface ocean. From the observation, which is from the satellite data, from the model, and then a comparison of both using a contouring algorithm. And so the idea behind that is to combine satellite data with numerical modeling in real time. So for now it's not implemented in real time, but we are working on that, to provide a real-time control of the forecast of the model, to give some confidence indicators associated with the forecast that we are providing, and maybe later also to implement some data assimilation of this satellite data in the numerical model to improve further the forecasts. And so here are my conclusions. So we are using the CMEMS products, so mainly numerical model forecast from the CMEMS system, and we are downscaling this solution to take into account the effect of the regional ocean circulation on the nearshore water quality. And so obviously the strength of the CMEMS service for us is real-time availability, because we are mostly working on real-time application. The information, the 3D information about the hydrodynamics and salinity and temperature on this property that are affecting the ocean circulation in the coastal area. Although the efficient downloading procedure, which allows us to download the data, to recover this data in real time, or subset of this data, and of course the fact that it's free is an important strength of the service for us. So some proposal of evolutions of the service that could be important for us regarding the downloading procedure. So for now, for what we understand now, the main script and procedure available are proposed in the Python language, and so maybe it could be interesting to have alternative procedures to download this data, to have the choice of the tool that we want to use to recover the data, especially in real time. And so it has been already mentioned this morning, but we are really interested in information about the sea state, so I think it's coming soon as part of the CMEMS product. But regarding the sea state, will be very interesting in having the full spectral information, the result from the regional wave model or global wave model. rather than bulk parameters, because for most of our applications, it's the spectral information, the full spectral information that we need to force a constant model. So that's it from me. Thank you.